Question number 3. Why is pyridine more basic than pyrrole? To know this, we first need to introspect the structures of pyridine and pyrrole, and secondly, we need to know the state of hybridization of the nitrogen atom for the pyridine ring and the pyrrole ring. Let us first look at the structures of pyridine and pyrrole. X-ray diffraction measurements show that pyridine and pyrrole are planar. That means all atoms of pyridine and pyrrole are in one single plane. This is only possible if all atoms undergo sp2 hybridization, because it is only the sp2 hybridization that permits a planar geometry. Therefore, all the atoms, including nitrogen, of the pyridine and the pyrrole are sp2 hybridized. Now let us look how sp2 hybridization takes place for nitrogen. For this, we write the atomic number of nitrogen, which is 7. This is the electronic configuration, and here is the orbital diagram for the electronic configuration: 1s2, 2s2, 2p3. Let us first look at sp2 hybridization of nitrogen in the pyridine ring. 1s and 2p orbitals mix and merge with each other to form 3 new sp2 hybrid orbitals. The pz orbital does not take part in hybridization and is written as such. Now, one of the sp2 hybrid orbitals contains the lone pair of electron. There are other two sp2 hybrid orbitals containing 1 electron each, and they go for a head-on overlap with the sp2 hybrid orbitals of these carbon atoms on either side to form the Nc sigma covalent bond. Now, of course, there is a pz orbital that remains unhybridized, and because it is unhybridized, it remains perpendicular to the plane of the molecule or to the plane of the overlapped sp2 hybrid orbitals. This pz orbital, which is unhybridized, is now free to have lateral overlap with unhybridized pz orbital of sp2 carbon atoms on either side, and that results in delocalization, aromaticity, and an aromatic sextet. That is, it is the electron in pz orbitals, they contribute to all the 3 of these. On the other hand, the lone pair of electron is in sp2 hybrid orbital. It does not go for lateral overlap with the p orbitals simply because it is in another plane. It is on the plane, it shares the same plane as that of the plane of the molecule. Therefore, it won't go for any kind of lateral overlap. Thus, the electrons in the sp2 hybrid orbitals on the nitrogen atom for pyridine are localized. They do not participate in any kind of delocalization. Now, let us look at the sp2 hybridization of the nitrogen atom in the pyrrole ring. Now, this is completely different from what we have seen in sp2 hybridization of nitrogen in pyridine ring. How this occurs is being explained here. Before hybridization takes place, the electron in the 2s orbital jumps to the pz orbital such that the pz orbital consists of the lone pair of electron. It is now that 1s and 2p orbitals mix and merge with each other to form 3 new sp2 hybrid orbital. Each of the sp2 hybrid orbital now consists of one electron, and they go for a head-on, two of them go for a head-on overlap with the sp2 hybrid orbital of carbon on either side to form the Nc sigma covalent bond. One of the sp2 hybrid orbital goes for a head-on overlap with the s orbital of hydrogen to form NH sigma covalent bond. Now there is a unhybridized pz orbital which consists of lone pair of electron. Because it has not taken part in any kind of hybridization, it lies perpendicular to the plane of the molecule. It is now free to have lateral overlap on other unhybridized pz orbital of carbon atoms on either side. And thus the lone pair of electron in the pz orbital of nitrogen in Pyrrole contributes to delocalization, aromaticity and aromatic sextet. Let us now revisit our question, why is pyridine more basic than Pyrrole? The answer to this is, in pyridine the lone pair of electron are in sp2 hybrid orbitals. Being in sp2 hybrid orbitals make it localized because they are not in the same plane as that of the pz orbitals, and thus they do not take part in any kind of delocalization. As they are localized, they do not participate in delocalization. They are more readily available for any proton or for any Lewis acid. On the other side, if we look at Pyrrole, the lone pair of electron is in a pz orbital which can go for lateral overlap with unhybridized pz orbital of carbon atoms on either side. This can result in the lone pair of electron being delocalized. And because it is delocalized here, it would be harder for a proton to accept a pair of electron or for a Lewis acid to accept a pair of electron. And this is the reason why pyridine is more basic than Pyrrole.